Hi all! Today we are going to talk about how to drink through a straw. Drinking through the straw is a lot more complicated in Calc II, so we're going to spend some time on how to drink through a straw. We want to start with our work equation because we're going to talk about how much work it takes to drink through the straw. And our work equation is right here, this rho g from a to b of ay dy. So that's the area of each layer of water we're lifting, and this is how far we're going to lift it. And we're integrating each layer of water to find the entire work necessary to lift all of the layers of water. So this one is going to combine some ideas that we talked about with emptying tanks with some of the ideas we talked about for our dam problems. And part of that is going to be because of this straight line on the outside of our cup defining our radius. So each layer of water, because according to the problem this is a round cup with a radius, is going to be the area of a circle, pi r squared, and r squared anywhere on the cup will be the distance from the y-axis to the outside of the cup squared. So before we start any math, we're going to make this note to convert our centimeters to meters for the simplicity of units because both of these are already given in meters. So let's say 14 centimeters will actually be 0.14 meters. All right, so let's start finding the equation for this line, this gray line on the outside of the cup. So we'll start with, moving this thing out of my way, we'll start with m is equal to 0.14 minus 0 over 0.04 minus 0.03. That would give us 0.14 over 0.01, which is just 14, which makes sense. For every 1 centimeter over, we go 14 centimeters up. So every 1 meter over, we would go 14 meters up. So using our m, we can use our y minus y1 is equal to m times x minus x1 equation. So y minus 0 is equal to 14 times x minus 0.03. And we would distribute. That would give us y is equal to 14x minus 0.42. We've got to solve because this is a dy problem, so we need this equation written in terms of x. So kicking 0.042 over to the other side and dividing by 14 gives us x is equal to y plus 0.42 divided by 14. And that's just our equation for the line, so the entire area, a of y, would be pi times that squared. So pi times y plus 0.42 divided by 14, all squared. All right, so now we have our area. Our distance that we're going to lift the water is from the bottom of the cup to the top of the straw. So that's 14 plus 6. So that would be, and that's centimeters, so we got to convert it. So that would be 0.2 minus y is the distance we're going to lift it at any point. Moving this into our integral, we have w is equal to rho g. Let's see, our cup is full, so we're going to lift it from 0 to 14. That's how much water we're lifting, and since that's in centimeters, we need to add our little point to change it to meters. Ay would be pi times y plus 0.42 divided by 14 squared times 0.2 minus y dy. So what I'm going to do is move pi outside, and then I'm going to square 14 and move that outside too. So that would give me, let's see, rho g pi, and 14 squared, which I should probably have memorized, but oh well, is 196 from 0 to 0.14 of y plus 0.42 over nothing because I moved the 14 out, squared, times 0.2 minus y dy. Okay, this thing has to follow me through the whole problem, so I'm going to name it, and I'm just going to name it some variable I'm not using right now. Let's see, a letter I'm not using. I'll name it capital B so that I can stop writing it over and over. So continuing down, I'll just have w is equal to capital B to represent that entire constant. From 0 to 0.14, to be able to integrate this, I have to deal with a polynomial, so I'm going to do the perfect square polynomial and then distribute to the 0.2 minus y. Y squared plus 2 times 0.42, which is 0.84, y plus 0.42 times 0.42, 0.1764, and all of that is times 0.2 minus y dy. So now I've got to continue working with those. B, 0 to 0.14. Alright, that's 0.2 times y squared, 0.2 times 0.84, which is 0.168 y plus 0.2 times 0.1764, which is 0.03528. Oops, gotta keep going. So that distributed the 0.2 to everybody. Now I've got to distribute the negative y to everybody. So that would give me a negative y cubed, a negative 0.84 y squared, and a negative 0.1764 y, all dy. And now it's just integrating a bunch of constants or a bunch of polynomials. Oops, I forgot the sign between these. Plus. Okay, so that would give me b times 0.2 divided by 3 y cubed plus 0.168 divided by 2 y squared plus 0.03528 y minus y to the 4th over 4 minus 0.84 y cubed divided by 3 minus 0.1764 divided by 2 y, all evaluated from 0 to 0.14. The good news is that there's a y in every single term, so the 0 doesn't really matter. We just need to plug in our 0.14 and then multiply it by our constant b, which was all of these variables, or constants. So that would be 1,000 times 9.8 times pi divided by 196, and then for the sake of moving this forward, we'll just do all of this math in a calculator. Okay, so using a super fancy calculator, we'll get 0.0041755 about. Oh, that's messy. Try that again. 0.004175. Okay, and then multiplying all of that together, we should get about 0.656, rounding to 3 decimals, and that would be in joules because we converted to meters at the beginning like we should have. Okay, so I hope that helps with drinking through a straw, which it turns out is really complicated.